Assalamualaikum warahmatullahi wabarakatuh. To my sweetie lecturer, Madam Nur Hafizah binti Muhammad. Today, I'm Nur Ain binti Muhammad Zaki and my partner is...
Hi, my name is Nur Ain binti Hasli.
We from DAN, GAN 4A class, would like to present about angular motion, chapter 8. Hi, introduction. Do you see Ayah Hasli?
Wait, yes, I see.
Okay, introduction about the angular motion is the motion of the particle as it moves along a curved plane with the analysis. Since the position, velocity and acceleration of a particle will be defined using angular displacement, angular velocity and also angular acceleration. Angular motion can be defined as the motion of a body which is about a fixed point or axis. It is said to be equal to the angle which is passes over at the axis or point by a line drawn to the body. Okay, next slide. Do you see application, Ayasli?
Wait. Okay, I see a slide.
Okay, I pass it.
Okay, application. Application of angular motion, like merry-go-round, clockwise and gymnast.
Next slide. Do you see tangentiality?
Yes. Functionality of application. Example omega is an example of circular motion because motion of the body moves along a circular path about a fixed axis. For clock, the rotation is counterclockwise is inbound and with the angular velocity in the same direction. And the angular acceleration is in the same direction as the angular velocity, which increases the rotation rate. The angular acceleration is in the opposite direction to the angular velocity, which decreases the rotation rate. Functionality of application gymnast and athlete spin, swing, twist all around and axis of rotation.
Okay, next slide. Do you see types and categories, Ayasli?
Okay. Type and category have three.
Right.
One, and first, angular displacement. Angular displacement measured in evolution, degree or radian. One evolution equal 316 degree equal 2 pi radian. Definition of the radian. One radian is the angle theta subtend at center of a circle by an arc length equal to the radius r of the circle. 1 radian equal 316 degree or 2 pi. 1 radian equal 57.3 degree.
Next slide. Do you see angular velocity, Ayasli?
Next, angular velocity. If a body rotates through an angular displacement in a time interval, its average angular velocity omega acceleration velocity and gravity. Average angular velocity omega equal theta plus time. Theta per time. The instantaneous angular velocity omega of the body. Average angular velocity omega equal angular displacement 2 pi n radian per time in second equal 2 pi n. acceleration. Angular acceleration is defined as the rate of change of angular velocity with time. The symbol for the angular acceleration is alpha, and the unit is radian per second squared. Reverse acceleration, alpha equal omega 1 minus omega 0 per time.
Done.
Next slide.
Next slide, do you see? Do you see my slide, Ayasli?
Wait. Yes. You see your slide.
Okay. Let's study with solution. The topic is relationship between linear and angular quantities. The picture show the rotation of a bicycle wheel. Rotation of bicycle wheel. In this question, we will apply the equation for constant angular acceleration to the simple case of a rotating bicycle wheel. The angular velocity of the real wheel of a stationary exercise bike is 4.00 radian per second at time equals 0, and its angular acceleration is constant and equal to 2.00 radian per second. 2. A particular spoke considers with the plus as exists at time equals 0. Figure 1. What angle does this spoke make with the plus exists at time equal 3.00 seconds? What is the real angular velocity at this time? The formula angular motion equation, first, omega equal omega 0 plus alpha time second theta equal omega 0 time plus 1 per 2 alpha time second. Third, omega 1 per 2 equal omega 0 2 plus 2 alpha theta. That's slide solution. Do you see my slide?
Okay.
Solution. Set up. We take theta equals 0 at the position where the chosen spoke is horizontal, and we take counterclockwise since of the rotation to be positive. The initial conditions are theta 0 equals 0, omega 0 equal 4.00 radian per second, and alpha equal 2.00 radian per second 2. So, we can find theta and omega at any time. The angle theta is given as a function of time. Theta equal theta 0 plus omega 0 time plus 1 per 2 alpha time 2 second equals 0 plus 4.00 radian per second multiply 3.00 second plus 1 per 2 multiply 2.00 radian per second per second equal 21.0 radian equal 21.0 radian multiply 1 revolution per 2 pi radian equal 3.34 revolution. Answer, the wheel. Do you see my slide, Yasmin?
Yes.
Answer, the wheel has turned through 3 complete revolution plus an additional 0.34 revolution or 0.34 revolution, 2 pi radian or revolution equal 2.14 radian equal 123 degree. The chosen spoke is at an angle of 123 degree with the plus as is. The wheel's angular velocity omega is given as a function of time by using omega equal omega 0 at plus alpha time. At time equal 3.0 second. Omega 0 equal 4.00 radian per second plus 2.00 per second multiply 3.00 seconds equal 10.0 radian per second. Alternatively, we get omega second equal omega 0 2 plus 2 alpha multiply theta minus theta 0 equal 4.00 radian per second as second plus 2 multiply 2.00 radian per second radian as second 21.0 radian equal 100 radian second per as second equal omega equal 10.0 radian per second equal 1.59 revolution per second. Okay, last. Do you see my slide?
Yes, just like I see.
Okay, conclusion. Angles are measured in radians. A whole circle is 2 pi radians. Angular velocity is the rate of change of angular position. Angular acceleration is the rate of change of angular velocity. The angular velocity and acceleration can be related to the linear velocity and acceleration. The frequency is the number of full revolution per second. The period is the inverse of the frequency. The equation for rotational motion with constant angular acceleration have the same form as those for linear motion with constant acceleration. Okay. Thanks to our lecturer, Madam Nur Hafiza binti Muhammad, for listening so well. Thank you. Bye.